let's take a look at the quiz itself. I mean, I guess I'm doing part of your work now, but that's okay. I want to make sure. See, the first question was solve and sketch the solution. I'm sorry, I used very shorthand notation here. I apologize for that. I took the whole thing and multiplied it by 6. I probably should have shown that I multiplied both sides by 6. And of course, that's legal even in an inequality. Why did I pick 6? And that means it'll wipe out all denominators, which is one way to do the problem. Could I have done it with fractions? Sure. You can also just add x over 2 or subtract x over 2 minus x over 3, get a common denominator. Could have done it that way. I just prefer this idea of getting rid of the denominators. It seems to simplify the problem. In fact, in this case, look, it just becomes quite simple. It's just x is greater than 30. We got the solution. I didn't show the graph here, but what you'd want to do is either have an open dot at 30 with a bar shading out to the right, or the other correct notation is a rounded parenthesis with shading out to the right. The more common notation is, if you don't want to include the point, use a rounded parenthesis. If this was x is greater than or equal to 30, then you would use a square bracket. But I still like, open dot, don't include, solid dot. I'll accept that too. Okay, any questions on the first one? By the way, I really didn't try to trap you in any way. I honestly, in some cases, picked medium. In fact, this was this was supposed to be one of the easier ones. I wasn't trying to, really give you a tough one. The second one was solve and sketch. Oh yeah, this was your absolute value problem. And the first thing you had to remember is when you do an absolute value less than problem, you wind up with a kind of a sandwich, something that's caught between two values, and you have to do an intersection or an and. You break it into two parts. The first part, just kind of ignore the absolute value signs, and on part 2, change the sign on the non-absolute value side. And with an inequality, that's the equivalent of multiplying both sides by a negative, and you have to reverse the inequality. So you notice here, I had to change this to a greater than. Solve both sides. X is less than 2. X is greater than negative 3. The fact that where are those overlapping is the answer, gives you, and I guess I think the graph is lower. I got to scroll down. I think it's on there, isn't it? Yeah, I should have just lifted this up a bit. So if you use the dots, you would get something like that. If you use the parenthesis notation, you would just have two rounded parentheses and shading between. Any questions? I know going through this kind of quick, but you can always also use your book for reference. The third one. This was a little more challenging, but it could have been a lot harder. What made this a little more challenging is it's a little harder when you have to factor out, I'll call them chubby factors. Chubby meaning, it's not just a single term, it's a quantity. And what you wanted to do is what? Take out a 2x minus 1 to the third power. And I don't show this real clearly here, but that would leave what on this? So you got term 1, term 2. In term 1, what's left when you take out a 2x minus 1 cubed? Just this guy. So, and in term 2, what's left when you take out a 2x minus 1 to the third? 2x minus 1 to the first. And of course, that gets subtracted. So this is what you're left with temporarily when you factor that out. And then I combine those. What is x subtract 2x, negative x. And what is negative 4 subtract negative 1? Minus 3. So this becomes x minus 3. I'm sorry, negative x minus 3. Actually, that's pretty good. The only thing is there's one little opportunity here. You could factor out a negative 1, making this into an x plus 3, which then could be canceled downstairs. And so if you take that negative 1 out, that's going to cause a negative to appear. So you could have, instead of just a negative in front, you're going to have a negative 1. That's fine. And it doesn't matter if the negative is on top, on the bottom, or off to the side. It means the same thing. Okay. That one is more of a vision problem than anything. You know what I mean? Can you see that? When you get these chubbier factors, sometimes it's just a little harder to see it. The fourth one. This one wasn't nearly as hard as some of you thought. I don't blame you. Some of you thought, oh man, I got to do this PQ thing and I got to do all of that. Turns out you didn't need to do that because this was factorable. However, it's not really easy to recognize it's factorable. People that I had in pre-calc know I used to call this the divide and conquer type, where think of it as part 1, part 2, and in part 1 you can take out an x squared. Part 2 you can take out a negative 3, and voila. Even though this isn't factored yet, look at a common factor appears, which now you can factor. Take out the 2x plus 1, and what's remaining? X squared minus 3. Now we got it factored. Okay, now what do I mean when I say find the zeros? That's important language that you need to recognize. That means when will the function equal 0? So set equal to 0. Once you got it factored, you're kind of coasting from there, because then you just set each factor equal to 0 and finish it up. So here I said x squared minus 3 equal to 0. Don't forget, there's always two solutions. You always have, whenever you decide to take square roots, you got to do two. You always got to do both square roots. So plus and minus square root of 3, excuse me. On the other side, that's pretty easy. X equals negative 1/2. So we came up with 3 zeros. Plus root 3, minus root 3, minus 1/2. Could it be done by using the PQ thing and using all those other laws? Sure. Just turns out a little bit slower and more drawn out that way. But yeah, you. And the problem is, of course, this isn't a real. This probably isn't the first factor you try. Usually you try the whole numbers first, and so you would have wailed away for a while. And then you would have wound up with what? This left. So you could have gotten there the other way, but this is how I was hoping you would. So what am I saying here? I guess I'm making a statement that factoring techniques are pretty important. They're going to kind of keep cropping up, and this is one of those problems where factoring would have helped you. Number 5. Again, I got to move these up a little bit. Add. Well, we needed a common denominator because we don't have one right now. Before you get a common denominator, don't you want to see if this is factorable? Here again, factoring. Turns out factoring is fairly easily available. X minus 3x plus 1. So now you can see, I think, that the least common denominator is x plus 1, x minus 3. First fraction is only missing an x minus 3. The second fraction is missing nothing. So we don't need to do anything over there. I'll just ask if you have any questions there. all I did at the last step is to combine the numerator like terms. Can't do any canceling. And well, I just want to repeat. It's perfectly okay. I really prefer that you leave your denominator answer in factored form instead of multiplying it out again. Two reasons. One, if you multiply it out, you got a chance to make a mistake. I've done that where I did a real hard problem and I just wanted to do a little easy thing at the end, and then your mind kind of relaxes and you mess up. But more importantly, factors are better, because if there was a next step, factors really are handy for possible simplification. So anyway, I tried to pick one problem from each of the 5 assignments, and I tried to be medium in difficulty on those assignments. I wasn't trying to pick the hardest, and some are a little harder than others, but anyway, anybody question? You know, it still needs to be said one more time. While all of that stuff should be in your background, and I know we have little varied backgrounds because of, well, we just took different courses and had different kinds of instructors and who knows what. Still, there's a lot of algebra that goes before this course, and it's kind of overwhelming when you look at it all together. So, questions? I guess let's, everybody clear on what the deal is by Monday then, if you want a chance to raise that, you have that option of handing it in along with another sheet. Okay. Let's get into new material here. We're going to go finally start chapter 1. Now, you're going to notice there's some review here too, but it's not as spread out. We're going to be focusing in on some things, and already you're going to like that because there's a lot less, I don't know, you don't have as much to worry about at the same time at least. So lesson 1.1. In the book, it's got a nice general title, the Cartesian plane and the distance formula. And by the way, the whole chapter 1 is all functions, graphs, and limits. Limits is starting to get ready for calculus. Functions and graphs are kind of prereqs again. So we're still doing a fair amount of review. I guess if some of you are wondering, when are we really going to do calculus? I'd say the end of chapter 1 and chapter 2. So we're still getting ready. We're on our way. So, the distance formula. I'll show you this slide, but you know, maybe I should just start over. That'd be better. So here we go. Let's set up a little coordinate axis here. I guess I got to turn this thing on for it to work. So if we have, you know, a Cartesian graph, and we have one point, and then we have, and these are just supposed to be generic points, so that's why I picked one in one quadrant, one in another. And if we call this point x1, y1, and this point x2, y2, just so we can differentiate them. My goal, and I guess let's change color here. Yeah. I guess we'll just leave it be black. I want to find the length of that. And of course, that's called the distance formula. And well, we're going to put in a couple other dotted lines here. If I just sketch the horizontal coordinate here and the vertical coordinate, of course, what we come up with is a very familiar right triangle. And this point down here, you're going to have to figure out. Look at it. what's the x-coordinate of this point? Because it's completely below this one, doesn't it have to be x1? And what's the y-coordinate of this point? Because it's horizontal from this one, wouldn't it have to be y2? Okay? And of course, you guys all know this. You wouldn't be here if you never heard of Mr. Pythagoras. You know what I mean by that too. The legs squared and added up will equal the hypotenuse squared. And isn't it fairly easy? What's the length of this leg here? How far is it from here to here? Isn't it just y1 minus y2? You know, the higher point minus the lower. And there's no angle, so I don't have to worry about x at all, do I? So that's y1 minus y2. And what's the length of this leg down here? I didn't leave any space for it, but isn't it x1 minus x2? Well, then using the Pythagorean theorem, and let's just call this, I don't know, d, this hypotenuse or distance, isn't it, okay, the hypotenuse squared equals one leg squared. I guess I'll do the x's first. Plus the other leg squared. Okay, and if we just solve for d, now here I'm only going to take one root. Am I disagreeing with myself and what I said earlier? Always take two roots. Well, the reason I don't care about the negative root is we're finding a distance, and unless you're talking Star Wars and hyperspace or something, sci-fi like, we don't know what a negative distance is. So we'll only worry about the first. And what we get out of this is the distance formula, except usually we say x2 minus x1. It doesn't matter, because what happens if you reverse x1 and x2? Well, one's going to be positive, one's going to be negative, but who cares, because you're going to be squaring it in a moment anyway, right? So it'll come out the same. And so, I'm assuming everybody is very familiar with this. That's called the distance formula. Okay, that's going to be a pretty important tool. Okay, and then this one I'll just show you a slide I've already got done. Actually, there's a couple things here, so you don't get too overwhelmed. Let's do one at a time here. Okay, the midpoint formula. Once again, if we take two generic points, x1, y1, and x2, y2, we can make this same horizontal and vertical coordinate. Only this time, what I'd like to know is, what are the coordinates of the point that's halfway between point 1 and point 2? Which we, of course, in geometry call the midpoint. Well, isn't it going to be true that when I do the horizontal and vertical lines here, aren't they going to split these two guys in half too? They have to, because of geometry, don't they? So, what's the x-coordinate of this point? Isn't it halfway between the other two x-coordinates? Yeah. And so, x-coordinate of our midpoint, the average of the two x-coordinates, x1 plus x2, divided by 2. And isn't this also going to be the height of the average of the two y-coordinates? So, that's a neat way to remember it. Midpoint, average of the x-coordinates, comma, average of the y-coordinates. And I'm sure you had that before. Okay, that'll come in handy. Oh, let me show you the bottom of this now. Okay. This is all about finding the equation of a circle. And I've set it up as a generic circle that has a center at h comma k, and I really did mean to use that. That's you're going to find hk. The coordinates hk are often used to represent a key point, like the center or the vertex of a parabola, or usually it's center. So here's our center, and then a generic point, which is on the circle, I'm going to call xy. Now, how do you define a circle? Think back to the old geometry days. What's a circle? All the points that are a certain distance from one point, right? So, like, if this is the point, and I want to find all the points that are 7 inches from it, I'm going to get a circle, right? Well, in 3D, I'd actually get a sphere, but on a plane, I would just get a circle. So, points that are equidistant. Distant. There's that distance education. Distance education. Oh my goodness. I was talking to somebody about distance ed this morning. Distance formula, excuse me. So, we'll call this our radius, r. Isn't that just an application of the distance formula that we were just talking about a few minutes ago? Square root, difference of the two x coordinates, x minus h squared, plus the difference of the two y coordinates, y minus k squared. Okay? And if you square both sides of this, goodbye root looks like this. And that then is really an important form in the rectangle. It's a good old general equation for any circle whose center is at hk and whose radius is length r. And isn't that just the Pythagorean theorem? Okay? So, let's quick practice. What if I said you have a circle whose radius is 7 inches and whose center, let's say, is at -1, 4? Well, using this right here, we should be able to write what? 7 squared, 49, equals x minus h, with x minus a -1. That's really just x plus 1, isn't it? Plus y minus k, y minus 4 squared, and this one down here is just another one I asked. I should just erase that. I think I just made one up in class that said what would be the equation of a circle whose radius is 8 and whose center is -9, 1. Can you see that? Radius, 8. Center, -9, 1. Notice in this form, the h and the k are always subtracted. So if I want to get a center at -9, I have to subtract a -9, which makes it an addition. And if I want, okay. That's another big one, the equation of a circle. And that's going to come up in our assignment. Okay, let's practice this a little bit. I'll have to scroll here. But I just made up a problem here. What's the equation for a circle whose center is at 3, 5, and whose radius is 7? Well, standard form. Well, I used the distance formula. I could have gone right back to standard form. The radius squared, 49, and then, isn't it x minus h, quantity squared, plus y minus k, quantity squared, and we're all done. You can write an equation for a circle then pretty quickly. And just remember, h comma k always stands for the center, r always stands for the radius. Okay, why don't we, let's see, what else? So, 3 big things so far. Distance formula, midpoint formula, general equation of a circle. with movable center, HK, and with radius R. I'm assuming that at least sounds somewhat familiar to you. Also, I'm also not going to spend time reteaching you the quadrants and how ordered pairs work, because I think that's pretty basic, and you should have that. I don't think that's too much of an assumption, is it? The stuff on page 2. Shouldn't take you long to bring that back. So I guess those are the 3 major things. So let's look at some sample problems, okay? So in your book on page 8, and I'll tell you what, we'll jump ahead here. I'll show you what the assignment's going to be. One to 33, the odds for next time. Okay, assignment 1-1, 1 to 33 odds. But now we're only focused in on 3 topics instead of about, I don't know, 60, where we were in the review chapter. Okay. In fact, I think I'd even argue do we really have 3 today? I mean, isn't the midpoint formula very similar to the distance formula? And isn't a circle formula just a distance formula? So really, in a way, we're focusing in on 1. Yeah. This is due for tomorrow. Yeah. Normally, assignments will be due the next class. We make exceptions for things like this quiz correction thing. But, right. Okay. So let's pick out some problems. And usually what I'll do in class, I usually do evens, but sometimes we'll do an odd. So let's take a look at the first part. They've got some right triangles drawn, and they say to you, find the length of each side. I don't think we need to do any of those, do we? That's called counting. With the exception of the hypotenuse. How are you going to find the length of that? Well, once you know the legs, then you can use the Pythagorean theorem, right? So let's quick do number 1. What's the leg? What's the vertical leg length? What's the horizontal leg length? What's the hypotenuse leg length? Not leg length. What's the hypotenuse length? 5, because 3 squared plus 4 squared equals 5 squared. Now, that doesn't always work so neatly, right? Okay. All right. Part 2. Plot the points, find the distance. So that's the same as part 1, except here they actually make you plot the points first. Okay. Let's go on to the 3rd section. Show that the points form the vertices of the given figure. Okay, so like in number 15, they give you 3 sets of coordinates, and they say, show me that that's a right triangle. So we got a little bit of geometry thinking here. How can we prove that those 3 points form the vertices of a right triangle? Well, what did we talk about today that's only in a right triangle? What? Yes. Right, but I mean, which principle, that's correct, which principle that we talked about today only occurs in a 90, when you have a 90-degree angle in a triangle or a right triangle? Exactly. The Pythagorean theorem is always true in a right triangle, and it's only true in a right triangle, right? So does that give you a clue how to do that problem? How would you prove that's a right triangle? You could demonstrate it with the Pythagorean theorem, but how would you do that?
You just draw it and find the values of A, B.
Find the lengths of the 3 sides, and then simply show that a squared plus b squared really does equal c squared. Right. Okay? How about this going down? How would you do the next one? How would you prove that those 3 form an isosceles triangle? What's isosceles? Okay. And so what did we talk about today that would allow you to demonstrate that you really have an isosceles triangle there? Do we have something that checks length today? Yeah, the distance formula. So what are you going to have to do? Get your well, they gave you the 3 points. You're going to have to find and show that 2 of the 3 distances are equal. How are you going to know which 2 they are? You aren't. Well, when you get 2 of them equal, all you got to do after that, last step would be smile, because you're done. Okay, next. How are you going to show that you have a rhombus? Do you even remember what a rhombus is? And I'll give you a clue, it's not an exotic dance. That's close by, it's a Roomba. But what's a rhombus? Let's see, let's take some thought. What's a rhombus?
It's kind of like, it's four-sided, isn't it? Kind of diamond shaped.
Yeah. Let's just try to nail it down a little more exactly. All sides are of equal length. So it's like a square that's been sat on. You know, just creeped off to the side. There is one more thing that's true. What do we call a figure? It's got nothing to do with the sides being equal, but what do we call a figure, generally speaking, that's been a rectangle and that's been tilted to the side so that the sides are parallel? Parallelogram. Yeah. And what are the things that are true in a parallelogram? Opposite sides are parallel, and opposite sides are of equal length. And opposite angles are equal or congruent. And there's all kinds of wonderful things here. Let's see. What's another one? I guess those are, the diagonals. This is all going back, way back. Diagonals, you know those 2 things in the center?
Well, like opposite corners.
Right. Opposite angles. What do you know about the diagonals? They what? Well, I was talking about a parallelogram right now. In a parallelogram, the diagonals bisect each other. In other words, they have the same midpoint. That might come in handy too, because today we learned how to use the midpoint formula. And then in a rhombus, even one more thing is true of the diagonals. Not only do they bisect each other, but they are also perpendicular. Anyway, you may have to do a little research to drag some of those things out. Yeah, we've already talked about parallelogram, so next section. Yeah, this is good. 19 through 22. How are you going to prove that those 3 points are collinear? First of all, what does collinear mean? Geometry question again. Collinear? You recall using that? They're all in a straight line. Now, what could you use from what I talked about today to prove that 3 points lie in a straight line? I know you can come up with this. Just think. You could use slopes, but we haven't talked about slopes today, so I'd rather not use that technique right now. How can you prove that 3 things line up? Well, go ahead, Darren. Okay, I think we're close. The only distance formula is the key, I think. The only problem is you don't know if that 3rd point is going to be in the center. But you got the right idea. There's 3 points, and I got to use the distance formula somehow. Well, maybe I ought to ask you this. What would happen if they don't line up? How could you find that out by checking distances? You know, you got one here, and one here. What would happen? What happens when I add, you know, here? I know you know this. I have 3 points here. Okay? And if I check this distance and this distance, what's going to happen when I add those two up and compare it to this distance? Which is shorter? Going around that detour city or going straight at it? Obviously, the shortest distance between 2 points is a segment, right? So what's going to happen when you add distance, I don't know, let's call this distance E to distance F. Isn't E plus F, doesn't it have to be greater than G if it's not lined up? And what's going to happen if they do line up? E plus F will be equal to G. So using the distance formula then, you could prove that 3 points are collinear. Do you follow the concept? So what are you going to have to do? You're going to be forced to find all 3 lengths. And then you're going to have to show that when you add the first 2 little guys, they really add up to the third. And they say in here, oh no, they don't say they're collinear and prove it. They say, tell me, are they collinear or not? So you're going to have to see if they add up. Let's see, a little more time here. How about 23, 24? It says, find x such that the distance between the points is 5. Okay, let's do 24 up here. Okay, we got the points in the book of 2, -1, and x2. And you want the distance to be 5. What value of x will do it? How are we going to go at this? Distance formula. Okay, so what's the distance formula? Right? Okay. And we know D. They gave it to us. I don't know, we'll call this point 2 and we'll call this point 1, okay, just so we can get them into the distance formula. Square root, okay, now what do I need here? x2, x, minus x1, okay, y2, 2 minus a -1, what is that? 3, yes. Okay. I'll raise it up so you guys can see a little bit better. So how am I going to solve for x? Okay, well, you can do it that way. Now, what's an organized way that will always work no matter how big or weird the numbers are? You could just ask Kyle because he knew. But what's a technique that you can always use? So put that in your notes. Ask Kyle. Couldn't we just square both sides? That'll get rid of the roots. What am I doing? Okay, and then I could subtract 9 from both sides. And now I could take the square root of both sides. And there's actually 2 answers. Because when you add 2 to both sides, well, no, Kyle, you're right. You don't have to go shucks. Because when you add 2 to this, you're going to get 6. When you add 2 to it when it's -4, you're going to get -2. And, well, -2... I gotta think about this. What were we supposed to do? Oh, actually, there are both answers. So, Kyle. I can't even talk now. He knew one of the answers. So you could be hard on him for not knowing the other one. You can thank him for knowing the other one. Okay. Sorry, Kyle. I got caught between Carl and Kyle. Okay, I think we've given you a pretty good sample. 1 to 33 odds. I'll see you tomorrow. Have your assignments ready to go. You might want to work on get that quiz project. Start on it. It'd be better to do it when it's fresh in your mind. Okay.